Good morning and good greetings. I'm glad I'm finally here to speak with people who are so involved in ferrocement. Probably you will help this become a better project if it ever happens, because you know more than I would about ferrocement. I approached a problem that I saw. I traveled to Thailand a few times, and the Philippines and Mexico, and I had worked on a ferrocement sailboat, and in the Virgin Islands I saw a hurricane destroy property and buildings, and I knew that water was 800 times as dense as air. So I asked the fellow who I worked on the boat with, why don't we turn your boat inside out? And it'll be very strong, and houses won't blow away. Anyway, I started studying the Virgin Island Building Code, and one thing that seemed important was the water collection. In the building code, every square foot of roof area has to be able to collect and store 10 gallons of water. And you have to have a cistern. Anyhow, ferrocement lent itself to the solutions of the cistern and the strength of the building. And I started studying it more. And Dr. Lilia Austriaca and I started to communicate, because she was the president or the secretary of the Ferrocement Society. And I wrote a paper about this design that's right there. And it was accepted pretty well. And of course, they always said, oh, you never built one. And there were no calculations. So I did. I went down to Mexico and I built one with a lot of help from various people, like Professor Hernandez at a university in Mexico, and Professor Tony Nauman. He gave me a lot of advice, not about the armature, about the cement work. And I have a background in construction for 50 years, so I was very familiar with development of shapes. And I noticed, as I wrote here, imagine a line, a form, or a utilitarian purpose, and ferrocement will follow and create it materially with an aesthetic three-dimensional strength and durability. So I said, aha, this is a very good thing, because you can almost do what you want. Then I discovered you had to have it pass codes, building codes. And I was familiar with that because that's what I did in New York. I worked on renovations and conforming old buildings to the current code. I actually used ferrocement, not knowing I was using ferrocement. I was fireproofing the walls. You needed 1 hour code fireproofing. So the exterior buildings were stuccoed basically on wire, and I realized what it was. So anyway, I'll try to be quicker. We should go to the next one. And I had read about, I went to the World Housing Technology Center in Izmir, Turkey, because I was studying housing. I was about 40 years old and I was very into it. And I noticed there was no Volkswagen of houses, I'll call it, a people's house. I went to the UN's meetings and different meetings, and the big deal then was styrofoam with some kind of polyester, or polymar on it or something, on like fiberglass. So how do I, what do I do? Just click?
He'll handle the slides for you.
No, but how do I do it? Oh, music too.
Okay.
I'm trying to get to the next one. I must say, I haven't seen
You can
this.
use the mic, he'll handle the slides for you.
Okay, but how do I move them? Say next slide. Okay, there you go, thank you. As you see, I'm a Luddite when it comes to computers. I sit there with people. By the way, the illustrator Is there a pointer? There is. Is this a pointer?
Yes.
The illustration right there.
You can also use the mouse.
The mouse, right. I'm sorry I'm such a Luddite, but I really almost never touch computers. This illustration was done by Haejung Park, who's a very wonderful illustrator, and so are there many others. So here's a building I started to build in Mexico, as I had mentioned a minute ago. And turns out that it worked. In other words, my plans, which I had never built yet, I went down to Mexico with templates. And as you've seen other people here, they lay it out on the ground and all that. I did that. But I knew the connections would work, because I have a background in sheet metal layout, so ductwork. I'm a journeyman in Local 28 in New York City, and we did a lot of large squared around buildings, squared around ducts. And one building that I designed came off of that knowledge, the layout. So, and a lot of work that I hear from, a lot of the presentations that I hear is very little to do with the shape of the building. It's either the obvious flat, like all buildings, or not all buildings. I mean, I just saw a beautiful brick wall over there. It was amazing, actually. It looks like it should be near ships. It's like a ship. Anyway, the radial line development that I learned in the trade of sheet metal lent itself to ferro cement. And I was very familiar with reinforced concrete and armatures. And I decided for anything to be in a code, it has to have insulation. The simple things, insulation. And I noticed of the ferro cement buildings that existed at the time that I was studying, there was no insulation. I was in a few that Professor Hernandez had built in Mexico, beautiful buildings, and they had major trouble with air conditioning and like a little rainstorm inside the building, because it was so hot outside, and inside they're trying to air condition it. So it didn't work. So I decided I'm conforming a building to code when I designed this. And it did, by the way, become a building that's conformed to code. Somehow, oh, there it is. Here we go. Okay. I must say I haven't seen this presentation since I made it a month and a half ago, maybe. Okay, this is interesting. As I developed more and more, I noticed that a lot of the aspects of the intact structures building system can retrofit existing block buildings. See, I'm looking at this small. You see it nice and big, right? Okay. So the same roof system that's on the building that I built in Mexico can be placed on top of a block building that lost its corrugated roof, say. In fact, there was a man that made a presentation yesterday from Pakistan on a Zoom, and he was using ferro cement to strengthen the building, but he was talking about the corrugated roof. And I was saying, well, as you see on the top of this, right there, up here, you could easily see this. And I wanted to do it in Mexico, but I never got back. I had some health conditions occurred, and COVID and things. And it didn't happen. But I was starting, that's my shadow, taking a picture of it. And this is an illustration of what a retrofitted block building that was half happening with no roof. You could easily put a ferro cement system on top of it with these components, and it would also strengthen the walls by the legs coming down. And it would have a gutter system that then gave that building a water collection system. Okay, next slide. I'm boring everybody, perhaps. Okay, then my mind kept working, and I had visited various places like the Philippines and Thailand, like I mentioned. And yeah, I went to slums and what they call what do they call it? When they move people? I forget what they call it. Anyway, and the people weren't happy. They moved them too far away. And the porches on the buildings that they made for them, there was enough cement to build 5 ferro-cement houses. It was like cement. And no water collection, like a hose spigot outside. It was pretty nuts to see, and they spent a lot of money. So I was introduced to slums with people complaining that they were relocated. They wanted to stay where the slum was because that's where they came from or lived originally, and because of either a highway or urban development had made them move. Say their grandfather lived in that area and they had a village, but now they all had to get pushed into a little place, and they were probably given faulty building material to build the slums or something. Anyway, it was a problem. So I, as you see in this illustration, I created something I call the oasis, which would be a solution to a slum. And I believe this presentation is in the conference's book.
Yes.
So you please read it if you would like it. And this building system is 4 components, which you see sometimes. You see them here. There must be a slide with, there may not be a slide that hold on. I'm looking for the table, the fabrication table. Okay. It's in the book, I would think. This isn't the book, this is the presentation. There's more in the book. So anyway, it adapts to self-sustaining construction that people can learn vocations and that will carry them through to the next stage of their life. They not only learn about ferro-cement construction, they'll learn about, say if they built the oasis, they'll learn about food propagation, a fish farm perhaps, which I saw in the Philippines. There was a lot of people trying to have fish farms with barrels. You walked along the street, there's barrels of fish. They could have just had a ferro-cement pool and would have many fish. And they probably could run it better. Here we go. Now, I was asked in Thailand by a Dr. Ekasit Limsuan, a very good friend of mine and a very smart guy who liked intact structures. He said, could you possibly make an Asian design out of ferro-cement? And often I've been asked, can I have a different roof? Because supposedly this kind of roof is not, I must say, they didn't like the style of a Volkswagen, and it became the most popular car in the world. But even though it was the Beetle. So I think this system could be the Volkswagen of houses. Being that it'll pick people up from, and I can't see like people having their heart and soul in the shacks that I've seen around. I just can't. I don't think they do.
Which model is suitable for slum redevelopment?
So that is visited places.
Say that again?
Yeah, slum redevelopment or slum area.
Okay. Slum redevelopment.
Yeah.
This would be that.
Yeah.
Yeah. So here we are. The same components that built the elliptical design and the oasis. Here they are. You can see them right here.
It looks like temple.
Exactly. And that's why I did it in a way.
Praying place.
Heijung was, I have this in my yard. I have these armatures I have a building yard. I have these armatures, full scale, in my yard. You can walk around them.
Yeah.
You know, and Heijung was looking at it, and she said, the illustrator, she said, this should be a temple. Actually, you don't see there's a lot of beautiful things. There's a horn that comes out, because Thailand influenced me. The ways, and we didn't put it in this illustration. She changed it slightly, but the armature has a large horn coming up. And it's air and light. It creates the beam that lets the air and light in. That's what it does. Let's see. Maybe I can conclude. conclude with something very civil engineering orientated. I actually built this. Unfortunately, I have other USBs that I thought maybe I'd have the time, but I didn't. So here we are with this, and someday you'll see them all. I built this wall on Staten Island, New York.
Is there water storage or ferrocement water storage?
Yeah, in Staten Island, New York. I was asked. There was this hill overlooking the beautiful bay of New York City. It was people were losing their yard. The house foundation was there, but next to it was going away because it's extremely steep. And they didn't want to do railroad ties because they had, and they were rotted out by then. So they said, "Oh, and you think?" And nobody could put footings in. It was illegal to dig into the hill. And also, the footings would have been amazing for any kind of wall. So I said, I hung out in my head, and I said, I think I'll cantilever this thing. So we call this block a dead man. Something doesn't move. So I made dead men, and I had concrete beams, or I call them ferro-cement concrete beams, and a substrate. See this right here? This is the original grade, that line right there, say. So it's eroding away, and it's making a floodplain below. I'm talking about now, here, not Staten Island. This picture. And so my idea was, because I had seen step farming, they could either farm here, or it could continually go on a mountain road and save a road. In Mexico, there was perfect places for that. They would close the road. You almost have to dig your way to go where I built this house. So I thought of this, and I have pictures of the construction of it. They're not in this presentation. But anyway, I thought, you have a road, and remember, this wall doesn't have to be dime straight because it's ferro-cement. Ferro-cement does what I had said. It follows any form you want. So this would be like a ribbon following a road. And the water would go down, hit the slab, and the geotextile, which would capillary the water back. I'm sure everyone knows what a geotextile is. I learned about it in Angeles University, had a presentation, and I was at it. So I learned about that while I was designing this. Anyhow, the water would go down, capillary back to a perforated pipe system that would store the water in a water tank under the dead man, which also would add weight for the cantilever. So if you're thinking, oh yeah, the mountain's coming down, it's going to knock this thing off. Somebody told me that. It's not going to work. I said, I don't think so. You know why? Because now, you know how plants colonize? So now you'll let this eroded hill, it'll become vegetated. You probably have to machete your way through it because it's not getting washed away. So now you have new land when the mud plain dries, a place to put, same building that was built in Mexico, but it elongates. Same components. Very important. It's all the same construction. I personally think it's very important because I've run crews of 10 men. They don't know what they're doing all the time. It's like they're your hands. They're good men, but they better know what they're doing or nothing's going to happen. So we designed a few of these, which you see in the previous. These are like garden apartments. Now you have an option. You have a tank full of water, which will gravity feed to feed these factories or houses, pressure water. Or if you have too much water, which you would if it was long, you could send it far away where people need water because it's elevated. And if this is in an area where it's wet, you could send the water to where it's not wet. So there's a lot of options cooking here. I think I'm finished. Good. good for you. Anyway, please ask me questions. I think I have the answers. I thought about this so much. So I'm finished. That's the end of my presentation.
Thank you very much. I think if there are any questions we'd like to ask, okay, that's all right, very good. I think we'll pass the mic. So we'll go from the first gentleman over here.
I'll try to go to the slide that you're asking a question about.
You spoke about forms being used for getting structures,
Forms for,
like using form finding methods to build structures for ferrocement.
I don't mean forms like you pour cement in the form. No, templates.
No, the way of finding forms, like using catenaries or different types of getting curves where the force follows the
I
form.
have templates for these components.
And I wanted to, the question is, what techniques did you use to get the templates across? Like, what were the forms
I use
came out?
radial line development, and to make the form, fabricate the form?
Yes.
Conventional rebar technology, two benders.
No, for example, to get the curves across.
Yeah, I use radial line development, which is where you have if you draw a silhouette, you project it over. You project over to the silhouette and you graph it, and you flip it around, and now you have more or less a three-dimensional view of the shape you want. But these designs were based on an ellipse, so it wasn't very difficult. I actually didn't use the radial line development for that. I used it for the curve coming around, and I made a turkey tail. There's a lot of things that aren't here that you can't see. Let me see if you can see it. Wait a minute. See this?
Yeah.
Oh, this is the ferrocement wall being built on Staten Island. Excuse me. See what I'm talking about? I don't know. I went in order and it stopped or something. Oh, good. It's,
You can go to the next slide.
that's what that armature is. I bet you there's more. Now that I've found these, I don't know where they came from. Okay, that's in my yard. You see the snow covering a cage? It's up there.
Yes, yes.
Okay, that's what I built in my yard, the armature, for this particular design. And originally I thought it to be a medical center.
Okay.
So we made it look a little more sophisticated than, it doesn't have a fish farm around it.
Okay.
Well, it probably should. But there's the armature. And you see right here, right there, that is actually 5 18-degree angles,
Oh.
which gives you 360 degrees, or 90 degrees on each side, 180. And that's how all of these buildings get built point-to-point construction. It's built in the components. You don't have to lay anything out. You put up one component and it happens.
It is very difficult to fabricate.
It's genomic. I think it's called gnomonic.
Sorry?
G-N-O-M-A-N. I think.
Yes, pneumatics. Yes.
Okay, that's what it's like. It's like a flower. It
Yeah.
keeps going. And I'm trying to show it. You see that? I don't know if you see a yellow up there, a little bit, like
Yes.
yellow paint?
Yes.
Okay, that's what I call the turkey tail. It's like this. And they're 5 18-degree angles. This is from the radial line development. And they create 90 degrees. So you get 180 degrees happening. Okay. And from there, when you build this building, say, here's a better one, that you can see it better. The snow's covered in. If it was hot out, the snow goes away. Let's see.
Paint down. Yes.
Let's see. Okay. Well, now you're going to see. Here's how. Where do you go? Okay, I'll talk to you. There you go.
Okay.
You
Thank you,
right
sir.
here? This is good. You see right here? Here's how I lay things out. You see the. I'm glad this stuff's here. I didn't know it was here. when I move this, okay, right here.
One more question.
Yeah, one more question, we'll finish. Chris-
Thank you, sir, for sharing us so beautiful projects out of India. First of all, there are some queries. What software was used for analysis of such critical designs? The next question is regarding in your backyard, the structure you have prepared, then snow load was there. And what about seismic and wind loads? There are some queries regarding those type of loading.
This building was built without being engineered. Then it was brought to Naveed Amwadi at the Asian Institute of Technology and a PE in Newark, New Jersey. And it was engineered as built, this building right here. And it exceeded the model codes for seismic and typhoon. And I have those reports. They may even be in here, I'm not sure. See, someone worked with me on this, and they will always ask me, where are these things? And I have files of all this information. I don't know where it is.
They were seismic compliant, that's what he means.
What was the first question?
Which software was used for analysis of such type of structures? Software. Like ANSYS, STAT.
No, there was no, that was after the fact.
Okay.
In other words, I built it first. I just went down to Mexico with some templates I made that I imagined. And it's not that I didn't know what I was doing. I knew what I was doing.
Like he first built it and then did the analysis later.
And
I need comply.
basically it was his idea, like an architect.
Anyway, this
he got
one-
it designed himself, but approved from some other agency. So this is his.
This is a very interesting part right here.
I'll just share something. In the US, you got a PE, that's a professional engineer, chartered engineer who certifies. All right, who gives the certification that this is compliant with, safety regulations.
After construction?
Yes. No, he's done it that way,
Before.
but he's confident, He's been a stalwart for so many years, he knows, so he got it compliant. It compliant. Am I right? Show.
Like an ant, like this. Looks like this inside. He said, come down. That's why I went there. I happen to know a lot of the hombres up in the mountains from New York. So anyway, yeah, this lady. I'd like to say one thing, but please ask me the question first. Go ahead. Okay. You see this top corner picture?
Yes.
Ah, yeah.
Page up or page down. 1 minute. Can we help you?
Yeah. Okay. I just want that top corner picture. Also, here's the genomic part.
This
Okay.
one?
No, this one.
This one. Okay. What do you
Okay. Can you make it big? See, I know if I was sitting where I sit, I could do it in a second.
No, we'll do it.
And here, I'm not going to say I know.
All right. You want to see this?
The one I had up. I just
Oh,
wanna make
yes.
it-
We
can make it this one,
Yes,
make
yes,
it this
yes,
large.
yes.
There's a reason. Like people ask, okay, how did I lay this out? The sun one morning was perfect. Right here. You see this beam right here?
You can use this.
Yeah. You see right there?
Yes.
Oh, I see.
You can use
Yes,
your
I
finger.
know. Yeah, that might be better. Yeah.
Yes.
If I get used to it. Right here. That's the beam that makes that air and light down the center of the building.
You use the shadows.
And the way I laid it out was from the sun's shadows.
Wonderful.
Because I was looking at I think it was like a cathedral in Oaxaca, and the stairs matched the shadow perfect down the wall. I'm like, man, these guys were like, nobody was over there measuring anything. They were drawing that shadow. So that's where that came from. No, and the beam worked. You see it probably in. Okay, let's go back to I don't want to hit a button. Forget it.
What do you need?
Let's go back to normal.
Normal.
Yeah. I'm thrilled. I didn't know these. See, again, I didn't see this for 1 month, and I was always getting WhatsApps. Where's the presentation? I'm like, I didn't want to make others the same presentation.
Okay, which picture do you need?
Oh, okay. You see the beam right here?
This one?
Right there.
You want
Yeah,
that zoom?
Can't they? Okay, go ahead. Yeah. That's what's on the ground from the Shattuck, it's called. The Portland cement. It's got its own, what do you call that earth? Is it pozzolan? What do you call volcanic earth? Okay, it has its own, I'm telling you, it's like, man, this is great cement.
Here you go.
Okay, there's the beam up. That was laying,
Who's standing here?
that's Lencho, the man that I gave the house to. And by the way, those columns, the seniors put them in when I wasn't there. I would come down for 10 days, and we built a cistern, and we started the house, and they said, Senor, and we no entiende this casa. And they put the columns up as if we were doing a building that, like a slab roof or something. I said, we don't need them, but here they are. In fact, Naveed said they're making it weaker. They're front-loading the earthquake. They'll break where the columns are, that's all. So anyway, that beam up there, which lets air and light in, was laid out by the shadows. Okay, I think I had my time. Thank you very much, everyone. Oh, one more question, right.
So I'm just curious, on your first slide, you had like some kind of heat map going on the, over your render,
On
right?
my what? First slide?
On the first slide, your introduction slide.
Let's go back to the first slide. I'm sorry, I have you
No,
jumping
that's
up
fine.
and
No,
down.
no issues, no issues. You're saying the first slide?
Yeah, the introduction.
I think you're talking about the computerization of it?
Yeah.
Yeah. That was done,
Understand what it represents, like what are you trying to
I-
study there?
I have these books of like all the calculations.
No, but what does that particular image try to say? Like what is it trying to say?
Could you talk in a microphone?
Yes.
Yeah, there's too much echo. Yeah. So what is it trying to say? What is that supposed to convey?
You're telling this image?
Which,
Yeah, that heat map.
okay.
Yeah.
What is this about?
No, the one in the center, the center.
Which one? This one?
Yeah, the colored one.
This one?
Yeah,
Follow
yeah.
me.
She wants to know what this is.
That's the way that Naveed Anwar, Doctor of AIT, that's the way he calculated all his calculations.
Okay.
In other words, I have it with me actually. I'll show it to you. It's a report that Naveed did, that's when he started telling everyone, and they built one on top of the roof at AIT. They built one of these.
Stress.
Anyhow, I believe it's a computerization of the engineering analysis.
And how have you camouflaged the rainwater harvesting that you were talking about?
I don't use
Camouflage.
camouflage.
How do you camouflage the rainwater harvesting system into it?
Camouflage.
Camouflage. How do you
Like, no, you
mean
said you
seal?
had to, no,
Camouflage means hide.
hide?
yeah, so you said you were supposed to store the rainwater, every
It's in this. Oh, okay.
square feet
Go-
of your roof is supposed to store the
Yeah,
rainwater and stuff.
go to where the four of them were at the end. That's a very nice question because it goes with the whole system, brings it with it.
Mixed.
I see the
No,
edge rib,
more.
I understand.
Where we have four up, like the building was being built.
This one, yeah.
That one.
Okay.
Okay.
Which one do you want?
Well,
Okay.
this one would be good.
This one. You want
Yeah.
it zoomed, or I think you
Yeah.
can talk from here, or
I can talk like reading. Okay, this
you can use the.
this is a gutter. This round, that's collecting the water. You can walk around the house in it.
Right,
And then-
where does it store?
The cistern, you see there's a line right there?
Right.
Okay, that's the slab.
Uh-huh.
Under there, before we put the house there, we formed using ferrocement that's forms, not wood forms. We formed a foundation that's holding this house.
Right,
Remember, look where it is. It's in a hill.
yeah.
It's a pretty rough place, actually. It dropped 40 inches in 40 feet, 45 feet, the elevation. And in that elevation, we put the cistern.
Okay,
So below the house is water.
right.
And what's really nice is it cools the floor. And the house, because it has that tunnel, that beam on top of it, which by the way is a ferrous cement beam, and the circles make it very light, so you don't have to support the beam. Naveed really liked that. I think they did it in AIT again. No, the water's in a cistern under the house. And because they're up high, could all happen anywhere, by the way, there's no special. You can see the slab in the top corner picture. That's the slab being built. That's the slab, okay. And they had to make another cistern because they had too much water. Like it collected, because the gutters are so big, it collects a lot of water when the storms come. It seems to have a magic of its own. In other words, it does a lot of things. And could you click on these just for 1 second?
Which one? The last one?
Yeah, the last one. Yeah. That was just, I noticed they were cooking outside when I was there. And I had designed this little building. That's when I discovered there's a ratio that any of these buildings can go like this. They can expand or contract. Same building system, I have a ratio for all the calculations.
Okay.
So you could have a building,
Parametric design.
it's nomadic, it's called, yeah. So anyway, it's a lot to kick around, but I think it could solve a lot of problems, because it is self-sustaining, and it's very easy to learn. It's not hard.
It seems there are many innovative ideas hidden now, camouflaged, like you are explaining. So to understand those, I think we need more time to discuss. Of course, we can certainly
Yeah.
discuss in break time. I have another question regarding retaining wall. Can you just please
Say that again?
Retaining wall.
Retaining wall. Soil retaining
Oh, yeah,
wall.
retaining
Please
wall.
open the slide.
Up here.
Which one?
You want the drawing or you want the?
Yeah,
marking?
drawing.
Okay, the drawing.
This one?
No, drawing, go back.
Can you switch off that?
Hello. Yeah. Hello. We are having problems like landslides,
Exactly.
having the steep slopes in hilly areas, particularly in our Konkan area. So I found this solution, can it be used for slope stabilization?
Slope stabilization, like
Yeah.
terrace farming,
Pardon?
like terrace farming.
Yeah,
Yeah,
terrace farming. Because here the purposes are combined, like collecting the water and utilizing.
yeah,
Again, saving the retaining wall from the water pressure.
yeah.
Collection is a very unique way done with the river slope and collecting in a tank. So all these ideas are combined together. But for slope stabilization, can we make just a chain of retaining walls around the hill slope?
I would think a farmer would know, but I think that, looking at it myself, as we all are, I think so. You know, I thought of that. In fact, it's in one of the illustrations of the villages. There's up in the mountain valley, there's a whole group of them going up. But they may not like the fact that the water stops. But I have a feeling there's a lot of runoff on terrace farming. I have a feeling there's, even though they're ancient and they existed a long time. But I have not been to it anywhere where there's terrace farming, so I don't really know the problem. But it's hard to say. But I could certainly see it physically, like doing it. Yeah.
Thank you.
I like it for a road, actually. I like the idea because it goes like this. In fact, the lady that I built that wall for wanted me to keep going, but her neighbors said they don't have the money sometimes. So they were letting their hill run away.
Yes, thank you.
All right. So, any other questions? I think we can network during tea time. As you can see,
Thanks for your patience, by the way. Yeah.
during tea, thank you so much. You can interact with them. Thank you very much, Owen, for your presentation. It's always nice to listen to you. And as you can see, this passion shows up. He's been coming for the past 10 years continuously. And he's visited all the slums around and seen what solutions can be done. He's told me, I shared a little bit with him about the highway system also. He's got a lot of ideas and a lot of things to learn from. So thank you once again. Please give him a big. So thank you very much. I know we
the project difficult and the part of it. So, so basically, in just 2 lines, what is ferrocement? So, ferrocement is basically the combination of 4 to 5 basic things.
You can skip that.
You can skip it.
So no issue. So architect is Aniket Shegde, structural engineer Himanshu Turpure. Built up was around 5,400 and plot area is 21,000. These are the construction phases. Yeah. So this is the first step. The RCC part was done already. We had to do ferrocrete roofs and arches. This was the preparation of line out. We did the line out on the site on that PCC and then the arches were created according to shape as per drawing. And this way the arches after when we made it, welded it or fabricated it, we put it the columns, dowels were already by the client only. We just have to attach that arches. Yeah, in this way it were created. It had a different sizes of 3 meters, some 6 meters, 3.5. Fabrication of arches is done in this. This is its internal part about stirrups and all. This is the V-beam shape which comes, I will show you further and where it comes. So this was a difficult part to make. Thoda structural is difficult. This is the basic structural design what have been made by Himanshu sir and the architect. So I will show you on the this all are the arches, arch 1, arch 2. Everything you can see in the red line are the arches, and this part is the external which has been come out. I will show you in the actual on-site drawing. So the center were V-shaped and the exterior were the rectangular boxes beams, arches beams. So this was as the height. I will show you why we used the crane, because the arches, the span was around 45 meter in length and width was 30 meters. So the arch was so big. If you remove the diagonal, the arch was so big that it couldn't be uplifted by the workers or laborers. So we on site we had a hydra and we lifted with hydra and we put it in the positions as per the drawing. See. So this was the alignment, the Vadamba, what we say. It was very difficult to maintain, but still we did it. All the staging was done because without it the stability couldn't be up. See, these are the 2 main arches for which we had a little difficulty, because the left side which you are seeing heighted one, it is 9.5 meters and the right side is around 6.5 meters. So, and it is thin, so it was moving very much. So, but we could manage to do it. These are the square beams. Yeah. Front elevation of restaurant. These are the V beams, and here also the most difficult part was that how we will join the center of the restaurant, how we'll take that, but that was also managed. I will show you in the photos. Yeah, this is the beam assembling work, arches. Only the center part were V beams and the outer all beams were square beams made in ferrocrete completely. This is the erection of steel bars for roofs as per the shape. Yeah, this is one. So weld mesh and hexagonal mesh fitting is also the part of ferrocrete which we do, as it is a process, and this, in the same way as we cast all other structures, we have done same for this. Same 2-layer chicken mesh and weld mesh we have done. So the shape got automatically formed. See, these are the photos. So after just okay, so yeah.
There are some points where concentration of reinforcement is खूप गर्दी झाली असेल असं.
Yeah, so in photos also you cannot clearly see the convention because इतके एकात mix झालेत की नंतर ते photos मध्ये पण
How could you manage that?
we did it stepwise. So एकाच वेळी सगळं नाही केलं, आधी एक काही आर्चेस मग
Step by
त्याच्यात
step, yeah.
स्टेप बाय स्टेप केलं. येस, सो इट वॉज इझी फॉर अस टू अंडरस्टँड. या, दिस इज द कास्टिंग. आफ्टर कास्टिंग मग तो शेप कळतोय एक्झॅक्ट कसं झालाय तो. Earlier, if you could see only in raw structure, you cannot identify that how the shape has been done. So this is the application of mortar, as you know, casting ratios and all. So this is the inside of it after casting and plastering.
Was it done simultaneously or step by step? Mortar filling?
Simultaneously, means
Mortar
for
filling,
front side,
outside first and inside afterwards? or
Ha.
whatever?
so
Did you put Pharma inside?
no,
No.
shuttering is not
Not necessary.
not necessary for ferrocement. Yeah, that point I forgot to say. Shuttering is not at all used here. It is
But
completely.
sometimes people use it. You have not used it.
We have not used in any project.
This is the beauty of ferrocement.
Let us complete
first, then we will ask. Please continue.
Yeah, sure. So yes, this is the last front view of the structure. Yeah, this is the completed. This is the completed work, and tomorrow, as you are traveling there, you can see it in actual on-site project. How and it is now. It is looking very nice. Yes. Yeah. Thank you. So, if you have any questions, you can ask. And my father is also here. He can also answer the same.
Let us first congratulate to both of you for this amazing structure.
I request Nanda Kumar ji to please stand up. All of you may not, some of you may not know him. So these are the two people who have built this structure, and we will be visiting Rudrana Bar and Kitchen tomorrow. I don't know if the bar is open.
Sir, सांगले sir. तो माईक बंद करा.
Difficult project to work as per shape because the span is center height. A big arch. Hollow beam. And hollow beam lift and fix is a very difficult as per architectural requirement. It's very difficult to fix at point. It's very difficult to join two beam in cross sections, and also the inter beam was V beams. So very difficult to fix with a plumb. Outside all beams are a square box, but inside beams means
Presentation. Sir, you will look at the presentation.
this all AR7 and AR6, AR7 and AR6, AR5, all beams are V beams, and it's very difficult to fix. Also, a gap between AR7 AR1 is a very huge gap, and in huge gap with a 1 feet by 1 feet, 300 mm by 300 mm, 8 mm bar, spacing exact position with the exact shape was a very difficult task. We took so many efforts to maintain the shape. You can see tomorrow at our visit in White. Because the shape is the beauty of these structures. It's a parabolic structures. It's only stand on box beam, nothing any rib provided to take the shapes or maintain the shapes or take the load. So we can make any type of structure, any type of huge structure through parabolic shape or through any round shape. That was the beauty of these structures. This project received 2 national awards. Because so I always invite college student and recruit student to visit there, and so many students visited there. Also, one interesting part of this project is the beam has up to certain limit or certain level तो beam असा हलत होता. It's very difficult to fix the perfect position. Why I am telling you why this was difficult. RCG is a very better, very easy to sustain straight wall or a straight column or horizontal beam. But in ferrocement, why ferrocement use such type of project? Due to flexibility of ferrocement. We can make any shape, any structures in shape through ferrocement.
कन्स्ट्रक्शनचे व्हिडिओ करून युट्यूबला टाकायला
Yeah.
एक व्हिडिओ आहे
एक-
तिथं
एक-
झालंय.
एक-
युट्यूबला टाका म्हणजे सगळ्यांना आपण सर्क्युलेट करू
आता एक 2 मिनिटाचा आहे त्याच साईडचा
तो दाखव म्हणजे ऍक्च्युअली डिफिकल्टी काय आली तुम्हाला ते
येस
Step by step, we after that we filled M10 concrete in beam because it's not necessary to fill the concrete in beam. Structural engineers designed to hollow beams, but difficult to plaster inside beams. Outside we can plaster, but how we plaster or how we finish, how will mortar to inside of the beam. So we just M10 grade concrete fill inside the beam to give the sufficient surface coating to inside of steel, not for structural, only to surface of cladding surface of steel. Designed the beam was box beam, hollow beam. It's important. This type of shape is maintaining with cantilever. With cantilever is also a challenging job. We'll see tomorrow the video of ferrocement.
व्हिडिओ
Just we'll see 1 minute video.
थोडं क्वेश्चन घ्या
Special foundation prepared below the ground.
Pedestal columns there.
साऊंड वाले
Pedestal columns.
साऊंड वाले कोण
RCC columns
Columns below that.
below that.
How much should they?
I think more than 6 feet because there is a light bottom side.
ओके
Okay. And then the floor slab.
Normal PCC.
PCC.
Tooling and PCC.
So clean beams were there.
Yeah, clean beam was there.
One more question there. So if we give 100 credits to you for this structure, so how much credits you will give to the designer?
Structural designer or architect.
both
इट्स अ टीम
because they are also equally
Yes, yes.
very good for this credit. किती घेता
50% to structural engineer
Okay, and
and 30% architect.
the total should be 100.
Remaining is his.
Because without his support, architect very easy to draw the drawing. But structural engineer is very difficult to design because in every project, these critical projects, we learn what to do in next project or what to not do in next project. That's a very important ferrocement. उसमें हम लोग सीख जाते हैं कि क्या करना चाहिए या नहीं क्या करना चाहिए.
I had a very similar question. Could you elaborate about the process between the engineer, the architect, and yourself? How the project evolved over the phases? Like, were there design changes involved because of the construction process, or how the design just evolved with time?
Nothing any change here. Only the height of entrance parabolic we reduced by 0.5 meter because it's a very huge height, and client also not feeling well to maximum height. So only we reduce 0.5 meter height. Otherwise,
0.5
total structure is
0.5 ने असं किती फरक पडणार आहे 14 मीटर तुमची टोटल आहे ना
total 9 meter in front. in front, in opening.
अच्छा ते 0.5 कमी केली तुम्ही.
Only 8.5 meters.
8.5 केली.
8.5 K.
8.5 केली.
बिकॉज टू एक हाईट आणि सेकंड हाईट हे मॅच व्हायला हवे होते. म्हणजे वन हाईट इज गोइंग टू मच हाय अँड अदर हाईट इज 7 meter. So they deducted by 0.5 meters. But it's what I am saying. Design is a very simple to draw on paper, but very difficult to do in structural requirement, and more than difficult to do in ferrocement or any RCC structure.
Execute it.
Yeah, execute it.
पण ते 0.5 कमी केल्यामुळे परत स्ट्रक्चरल डिझाइन बदललं.
No. Nothing much change. Nothing much change. Only to reduce the height 0.5. I will say you tomorrow. And whole structures, shapes, only 1% shape something miss by me, and because it's a very difficult to maintain the shape. Otherwise, all 5 shapes are exact as per drawing, exact as per shape.
That is what I expected from ferrocement.
I took so many efforts because every day thousands of people going that road, and I was clearly know that time nothing, any mistake should be raised in future because this shape is wrong. So money was no matter at that time. The quality of work and shape of work was matter.
मिळाले ना साहेब सगळे पैसे. आपण कॉन्ट्रॅक्टर आहे म्हणून तीच काळजी शेवटी. आपण फार करतो पण शेवटी पैसे भेटले पाहिजे ना. पार्टीच आहे का? मोस्ट डिफिकल्ट क्वेश्चन. पैसे मिळाले का?
Next.
Sir, I have a doubt here. It's fantastic presentation, fantastic project. Hats off to that. Suppose we go back in time, and my friend, structural engineer here, he proposes metal pipes instead of those box beams. What are your thoughts on that? If we do fabrication, so it not be much effort. We have the overall shape, and in segments we cut them. At site, assemble them. Your crane and all cost would be saved.
No, cost was not matter. Actually, in my 23 years of business experience, only 1 or 2 times I used only MS structures, because the property of MS structure and ferrocement is different. If we prepared the slab on MS structures, then crack always develop, because the expansion of MS structure, MS box pipe, and the expansion of raw steel or cement is a both different specification, characteristic.
But they are connected with the chicken mesh, no?
Yeah.
So
But
still there.
expansion, because the temperature variation in India to 10 degree to 40 degree. So it's difficult to maintain the crack on slab.
So what I can take away from here is, if I am doing any parametric form, the beams also needs to be in ferrocement.
So that would be better. This is the 100% ferrocement structure.
Thermal properties should be
So
saved.
Engineer Lele would like to answer this in a different way.
Actually, I have tried structural steel coated with ferrocement. Crack develop definitely. But if we can put spacer in between and join them with bolting, then this thing doesn't happen.
Okay.
Because that movement is taken by that hole and washer is there, it allows the movement.
Okay.
And ferrocement is intact in that case. That I have tried and I have used that way.
Okay.
You can do that way, you can design structural members, and that detailing is required in between.
It's possible.
It is possible.
So actually you can check railway constructions of the welding of joints, and that will give you more space for expansion is what he's talking about. I think there are a lot of theoretical studies on this. I'll get you to papers on this. So I think thank you so much. Any more questions? Sir,
Just
Sir, conventional concreting मध्ये आपण scaffolding आणि असं
shuttering in ferrocement.
that is the beauty.
That is the beauty. And because of this, we can make any shape. Because very difficult to shuttering the parabolic or round structures. So we are using always 3 layer of chicken mesh and 1 layer of weld mesh. And the chicken mesh layer, chicken mesh size is 12 mm by 12 mm, 26 gauge. It's 3 layers. Its only space is only 4 mm, 5 mm. And mortar ratio is 1:2.5, cement sand ratio. So it's automatically stick to chicken mesh.
सर एक बोलू
हो.
मॅडम असं एक बोलू फेरोग्रिडची ना हीच ब्युटी आहे की तुम्हाला ते वर्कॅबिलिटी किंवा वर्कमनशिप म्हणून खरं जर कॉन्ट्रॅक्टर याच्यामध्ये कमी काय आहे तर त्याला तुम्हाला वर्कमनशिप किंवा वर्कॅबिलिटी ऑफ मॉर्टर म्हणा किंवा काय ते कन्सिस्टंट ठेवावं लागतं. म्हणजे जर सर मगाशी म्हणले की 12 mm ओपनिंग आहे माझं, कारण एकतर ते कॉन्क्रीट नाहीये, एकतर ते कॉन्क्रीट नाही, इट्स अ मॉर्टर आहे 1:2 किंवा 1:3 रेशोमध्ये आपण ते करतो. फक्त मॉर्टर त्याच्याने कॉन्क्रीट खडीच आपण ॲग्रिगेट नाही वापरतो, कोर्स ॲग्रिगेट नाही वापरते, फाईन ॲग्रिगेट्स वापरतोय. आणि आता आपलं वॉटर सिमेंट रेशो म्हणा किंवा ते जे काय आपण जे मॉर्टर बनवतो ते असं नाही बनवा तुम्ही याच्यामध्ये तो इश्यू नाहीये, पण ती जी वॉटर सिमेंट रेशो जो तुम्हाला आहे ना तो तुम्हाला कन्सिस्टंट ठेवावा लागतो. कारण अदरवाईज शटरिंग नसल्यामुळे जर मी ते पाणी जास्त घातलं गेलं तर ते खालती पडतं, कमी घातलं तर ते टिकतच नाही. किंवा आता प्रत्येक स्टेजवरती सरांनी दाखवलं तर सरांनी तो प्रोजेक्ट केला, जर त्यांनी वेल्डिंग नीट नाही केलं त्यांच्या माणसांनी तर जाळी नीट बांधली जाऊ शकत नाही. नीट जाळी बांधली गेली नाही की त्याला माल नीट बसत नाही, नीट माल बसला नाही की स्ट्रक्चरला प्रॉब्लेम येतो. त्यामुळे प्रत्येक स्टेजला नीटच काम करावं लागतं आणि त्यामुळे प्रत्येक ती स्टेज वर्कमनशिप वाईज चांगली केली जाते. म्हणून फेरोग्रिडचा जरी कमी थिकनेस असला तरी तुम्हाला जास्तीत जास्त त्याचे रिझल्ट चांगले मिळू शकतात.
डेमो दाखवता येईल,
आपण डेमो पण टाकू शकतो आपल्याकडे.
सेल्फ क्वालिटी कंट्रोल
सेल्फ क्वालिटी कंट्रोल आहे, कारण शटरिंगच नाहीये. उद्या मी जर मला शटरिंग असते म्हणून आपण जेव्हा आरसीचं काम करतो, बिंग केला किंवा काही पण केलं त्याच्यामध्ये काही पण पुड्या चपला बिपला काही पण कॉन्क्रीटमध्ये पडून जातात, कोण बघत पण नाही, त्याला त्याचा अर्थच नसतो. आणि नुसतं फ्री फ्लो कॉन्क्रीट भरलेलं गेलं असतं. त्यामुळं सिमेंट मॉर्टर असल्यामुळं वर्कमनशिप आपल्याला मेंटेन ठेवावीच लागते.
वॉटर सिमेंट रेशो मेंटेन केल्याशिवाय ते
होतच नाही. वॉटर सिमेंट रेशो तुम्हाला मेंटेन ठेवावाच लागतो,
3.5
तुम्ही जास्त पाणी टाकू शकत नाही.
Thank you so much. Thank you, Mr. Zadav. Nandakumar.
Structures, how difficult they were to construct, everything at urban level. But as in India, you know, still 60-65% is a rural population. And how we can solve their problems with this ferrocement technology? You have seen how this structure was very difficult to construct. But even a small tank of 1000 liter or 2000 liter to construct at village level is also equally difficult. But in a different way, that everybody here who are from government and all other urban peoples are here mostly, they should know all those things. And we must work for the 60-65% people also. And how this useful at rural level, that I will show you. We begin with 200 liter ferrocement tank. You will laugh at me, what a person who is making a tank of 200 liters, but it has its utility. See, in Anardi Foundation wanted to make some 100 or 200 WCs in one village in Khalapur district. So I said, you will make the WCs, but where will the water will come from? Because people in village level are not using WC because there is no water. Water arrangement is not there. संडास बनाने के गवर्नमेंट की ऑर्डर होती है. तो हम बोले कि भाई ठीक है, we will teach you how to make a 200 liter tank, and we keep it just behind this WC. And if that tank remains filled up, then at least that will be useful for that one day. See, this is 2 feet 6 inches in dia and 2 feet because at village level still this feet and inches work. So I will talk in those terms. So this is a 200 liter tank. It is just fitted behind the WC. So if this tank remains filled up, naturally then the people from that village will use this WC. So even this 200 liter tank is very important. at village level. And now if you have to make a 200-liter tank at village level, hardly 1 bag of cement will require and some stand will be required. How you will bring it up, every quality and quantity and all that? All these things are difficult. But still you have to manage and construct this work over there. So even this 200-liter tank has a utility at village level. The skeleton is there and simply this mortaring. Now we will see what is the usefulness of 1000-liter and 2000-liter tank at village level. So when you go to village level, you will find that there is no storage arrangement at individual house. As in our urban area, we have underground storage tank and overhead storage tank for every apartment, whether it is a bungalow or it's a society, where we store that is 2 days water. So if even 2 days no water comes from municipal agencies, we can manage with that water. But at village level, per house, even not a 1000-liter storage arrangement is there. So we thought of making this 1000-liter tank, because if a family has a 1000-liter tank stored, then at least he will not have to go for 2 days outside to bring water. And another thing is at village level you get 4 feet dia weed mesh, means at taluka place you get 4 feet dia weed mesh easily available, and chicken mesh also. At 4 feet dia and 4 feet height a tank remains in an open, means you don't need any steel bar for that. It stands of its own. So only chicken mesh, weed mesh and mortar, you can have a 1000-liter tank. As I am an engineer, मेरे काफी सारे इंजीनियर्स कंसल्टेंट है, तो मैं मजाक में उनको बोलता हूँ, साहब मुझे जरा 4 फीट डाया एंड 4 फीट हाइट का डिजाइन दे दीजिए ना, वो स्टील बार प्रोवाइड्स करते हैं. मैं बोला भाई मैंने ऐसे काफी सारे बनाए, देन टेल मी व्हाई दे आर स्टैंडिंग, व्हाई दे आर नॉट फेल सो फार. छोड़ दीजिए हो, उससे की कोई जरूरत नहीं है. ओनली विथ वेड मेश एंड चिकन मेश यू कैन मेक ए टैंक अप टू 2000 लीटर. दैट इज 5 फीट डाया एंड 4 फीट हाइट. You don't need any steel bars, and such tanks are constructed many in our Konkan region. So this 1000-liter tank has a very is useful. At one village in Kardat Taluka, we made this 1000-liter tank for 5 tribal families, and they are kept just below this roof. So during monsoon, as you know, in Konkan we have huge rainfall. So during monsoon, these tanks gets filled up by itself. So during monsoon, they are not to bring any water from outside. And after monsoon, this tank, if it is filled up, then at least for 2 days, you are not to go. See, even a 1000-liter tank has a huge utility. This is what I want to say. This last tank is constructed at Uttarakhand. This was Uttarkashi, 2000-liter tank. Normally on top of individual houses in a bungalows, you will find this syntax tank is kept. So I used to go to Baroda many times, and in Baroda I told them, Kiba, instead of having this syntax tank, we will teach you how, you will teach your mason only, because then mason can go on constructing. No engineer is required, no design is required, no drawing is required. So like that we taught them, and at Baroda now they are making this tank. See, this is how beautiful it is. Because we have to remove this syntax from now, whenever you go to village, any water storage means you find syntax tanks only. So you can totally eliminate from 200 liter to any, up to 6 lakh liters also with this ferrocement technology. See, these are many tanks are constructed at very... Another thing in this 4 feet dia, what we have used is, we have replaced chicken mesh with natural fibers, such as banana. I will show you fibers. Banana fiber, coconut coir, and all this. Means only weed mesh and the natural fibers are there, and rest of the procedure is same. See, here you will find this coconut coir is there, wrapped to the 4 feet dia and 4 feet height on the left hand side. then cement slurry is applied and the plaster is done. If you tell this to the mason, then you did not go to the site also. You just provide them the material, they will go on constructing this. So this way we have used all natural fibers, because at village level natural fibers are available. We have used 3 types of natural fibers, that is banana, coconut coir and ambadi fibers. And such tanks are still standing. So we need some reverse engineering. Means we need now design and drawing for this one. And that has to be done now, because IS code is in a progress. Let us hope something will be there for village level, because everything otherwise remains for urban area only. That should not be the case. This is another 4 feet dia and 4 feet in height, with the help of 2-side formwork. I will show you the formwork. This type we saw, that is inner formwork and outer formwork in Orissa. Orissa, Bhubaneswar or Orissa, you go anywhere, you will find such type of farms. They have a 4 feet, 3 feet dia, 4 feet dia and 5 feet dia and 1 feet in height rings they are having. They bring 3 or 4 rings at the side, just fill it the gap, so that the tank of either 1000 liter or 2000 liter is similar to precast only, and there they use only weld mesh. So here we have constructed this tank. What we did, we casted first ring and then we lifted the formwork, second ring is casted and then third ring was casted. So this tank with only 10 mm thickness, weld mesh and a mortar gets ready. And still our designer says you need a steel bar for even such type of tanks. So such thing has to be there whenever this code or something comes up. See, these are various. On the right hand side, this is very common in Orissa and Bhubaneswar. This type you will see is there in every houses or even on roads also you will find such tanks in Bhubaneswar or Orissa. So now let us see what is the design aspect for this 4 feet dia, 4 feet height or 5 feet dia and 4 feet height. If you are consultant, he will definitely provide steel, because there is some minimum law, minimum percentage of steel has to be over there. So with experience and common sense, because we constructed the first, and now with experience and common sense, we are practicing this and uses this type of tank, and people are happy with it. Consultant may not be happy with it because he doesn't get any fee out of that. No credit. We wish that something will be there in a draft code which is under preparation. So we rural people should not be sidetracked. They should not be left out of this code practices. Let us hope so. Of course, we are no stalwarts, so we cannot say anything about that. We wish that otherwise, because other problem at village level is of sand. They say sand has to pass through this sewerage, that sewerage. No type of that sand is available. So what we say, what villagers are using sand to make their own houses. So mason at that village is comfortable with that sand. So we have used that sand only. We have not tested any sand or passing through this sieve and that sieve. We don't know even. And villagers also don't know even. But still the tanks are standing. Houses also are standing without intervention of any architect and consultant at village level. So then why can't this tank stand on its own? But we need some backing. Of course, if they give, it's okay. Otherwise, still we are going ahead. No problem. So let us hope so. And cost of these tanks, even 1000 is between 5 to 7 rupees. Means comparable to our this plastic tank. And secondly, once you teach this to the mason, then mason can go on working of his own, because this weld mesh and chicken mesh is available at taluka place. Cement sand, they know how to work it. Which sand to use for plaster, they know it better. And water cement ratio, see, if you make it a lean water cement ratio, बाल उसको पकड़ेगा ही नहीं, तो अपने आप water cement ratio बन जाता है, and tank खड़ा होता है. So this was the story of from 200 liter to 2000 liter, where you don't need any steel bar, but without steel bars, and they are having very useful at village level. So that should be covered as and when this any code or anything is concerned. Now we will go for usefulness of 5000 and 10,000 liter tank. Previously in 2000, there was government Yojana in Maharashtra that was known as a Pagodi Vir Yojana. And that time also the tank was ferrocement. No code was there, nothing was there. But still the tank was for ferrocement only. So we say means if a person needs a 5 liters of water per day, so 5 persons in a family, that is 5 into 365 days. So 9,125. So if 10,000 liter is stored water is there at every house, then he has not to go for drinking water quality and cooking water quality. So all diseases, major diseases in a village, means 50% diseases are there, waterborne diseases. So that will be taken care of if this rooftop rainwater system is there. But nowadays even everybody says that the borewell water is for drinking. How does this borewell water came for drinking? We do not know, but if everybody adopts this rooftop rainwater harvesting, problem of every house can be solved as far as both quality and quantity of water is concerned. And 5,000 liter is only for this purpose. In our Konkan region, many places you don't have water for 6 months or 3 months. So if you have a 5,000 liters water stored during rainy season, then you can use that water for drinking and cooking when this either well water or canal water, this stream water is not available after December or January. So this type of tanks, I will show you there are 4 different methods of constructing 10,000 liters of a tank. And you will wonder how design and drawing will be there for all these 4 different methods. So let us see what is first thing. This is known as this was for the Pagodi Vir Yojana, which was constructed to that is known as a one-side farmer. On this right corner, no, this on the left corner you will see this farmer is the inner farmer. To this farmer, you will find on this right hand side this wild mess and chicken mess is wrapped from outside. So support is there. See why we are using steel bar skeleton, so that still you will find the people are drinking water from the same time and they store it. So this is a one method of constructing. Why I am telling these 3-4 methods? These 3-4 methods should be covered in some these technical these things. So this is a cover one, the first method. This is a typical Pagodi Vir Yojana in Karjat Taluka. The typical tank is there. This is in Vadhav in Pen Taluka. These all tanks were constructed in 2000 and people are still drinking water. People say that after 4 feet you need horizontal rib and vertical rib. These all tanks are 6 feet in height. No ribs are there. But still they are standing. Then how they are standing it? They should have failed by the time. But no, still they are there and people are using it. So some design aspect of this has to be also there when this draft code is in the or when it comes out. This is another one where we have this steel bars means where this designer provides a vertical column and beam and all that thing. Same diameter and same this thing. Why? This we have constructed few times with this one also. Third is of course dome shape. For the dome shape, of course there are no ribs and anything. But this is also a way of constructing a 10,000 liter tank. This is another interesting which we saw. You see here there is no any water is not collected from any roof. the top of the tank is considered as a catchment. See, annual average rainfall in Konkan is 2.5 meter and above. So if you restrict your tank to the 80% of annual average rainfall, and if you keep a one hole while doing plastering at the top, if you normally we give slope at one direction, so there if you have a hole and if you fix a jali over there of 200 or 300 micron, one small filter, then whatever rain falls on top of this tank, because rainfall is 3 meter in Konkan region and this height is only 1.5 meter, so it will get filled up by itself. So this is another way of storing 10,000 liter tank, and this was constructed with steel bar skeleton and early. So these different methods use different type of material and different type of means everything is different in this one. Can it happen in any design? So much variation. But all these things needs to be mentioned or covered in whatever these things are likely to come out after some time. And cost of this tank are almost around 5 rupees a liter, even for the closed tank for 10,000 liters. Of course, these are all without profit. When we work at village level, 5 to 6 rupees a. Material required are well mesh, 2 inch by 2 inch we use, opening, and 12 gauge, chicken mesh, 3/4 inch opening, and 24 gauge, cement, sand, admixtures, water, cock coupling and all that. These are material are required. But this material required for different things, because when you use column and beam, so much steel will be required for the same size. Load steel bars are required for type 1 when you use inside formwork are very less. Then with the steel bar skeleton, you need slightly more. And when you have a column and beam, why people provide consultant, God alone knows, or he himself might be knowing it, but then I have not asked it. Steel bars are not required much less. As per the type 1, we have constructed many times. Ourselves also have constructed many times with this type 1. Type 2 also we have constructed many. With column and beam only few we have constructed. We have visited few times in Pen Taluka. Pen Taluka also you can see. As you visit this commercial activity and beautiful structures, you must visit at village level also, what things are happening and what wonder it plays, how people are happy even with 1,000 liter tank or even a 10,000 liter. Because why I tell my few friends are in Bombay Municipal Corporation and Mumbai receives 4,000 liters, million liters of water every day. They were asking me, भाई आप 10,000 लीटर के टैंक बनाते हो, ये क्या पागलपन कर रहे हो यार? मैं बोला भाई साहब वहाँ कुछ भी नहीं है, वहाँ 10,000 also it makes a lot of difference. But when they come to see the site, then they realize it has also some sense in this one. People are studying. This is all design aspect and consideration. For type 1, we learned it from one Karyakarta, that is Vivek Kulkarni. He is also engineer from Pune. For type 4, one Mr. Jain Kulkarni from Pune, he also taught us from how to construct. Because though I was an engineer, I was not knowing up to 2000 what this ferrocement is constructed. So, but when I went at village level, I thought that this ferrocement will be the most appropriate technology for village people. A mason will definitely understand these things. So I learned from these two people, and then from Milind Kulkarni and our other part, this trustee, that is Satish Kulkarni. They also give, but they give me design this column and beam. Then that is very difficult to work with, because even with that the things are standing. Then why we should go for column and beam? So we use as per our site requirement. They say when we go to at a rich person, he needs a design from a consultant. So naturally there we have to construct with column and beam. We don't mind because he also spends the money. But at village level, we cannot do it with experience and common sense. See, at village level, you have to work. You can work it with common sense and see many other things. Or you can develop your own the method of working also. That is possible. That's why ferrocement is interesting. Everyone can have a different way of executing the work. The experience and use of common sense, we have constructed many times with type 1 and 2. We have constructed many times. And user of the tank is happy. Quantity of material is required is very different in every type of this thing. For same 10,000 liters of a tank, cost-wise, one is naturally one side formwork is cheaper than other one, and with column and beam naturally it will be costly. The cost comes to around 10 rupees a liter for such tank. We wish that something will be there in a draft code which is submitted to the government of India, that is Bharat. I'll just drink some water. Our small ferrocement structures make a huge difference at village level, and 65% population in India is rural. And all we have come to urban area from rural area itself. So we must take care of those people also. Costing of tank 1 and 3 is around 7 rupees, and costing up to is around 10 rupees per liter. These are all closed tank. Cost also depends upon location and number of tanks. As we went to Uttarakhand at Rudraprayag, then it was at 2000 meter height. So even cost of taking one cement bag was taking up was more than the cost of cement. So cost varies. Now we will see other usefulness of 10,000 liter tank which is open from top. Because at village level you need, except drinking, for all other purpose you don't need any closed tank. If the open tank is sufficient for agricultural or horticultural purpose. So for this we have made with all these two different methods, and 10,000 liter also plays a wonder. Instead of constructing tank of more capacity, what happened? People said how they will manage with 10,000 liter of a tank. We say if a 10,000 liter at one in our Wada district, they are doing after monsoon all vegetable cultivation, so they need at least 1 lakh or 1,50,000 liter from December onward up to next monsoon. So we have constructed 10,000 liter tank for 10 families, and then from source, nearby source, because in Konkan region we get permanent source at least 500 meter or 1000 meter, permanent source is there. So from that source these tanks are filled up. So a 10,000 liter tank can solve the problem of 1,50,000 liter also. This coconut, these tanks, 10,000 liter tanks, I will show you the photographs. See, these are the photographs. See, even for Supari Bagh and all that, they are using this one. Because many from this Dapoli University, they were asking me, सुपारी और नारियल बाग के लिए ये 10,000 लीटर क्या काम करेगा? मैं बोला साहब आप मेरे साथ आओगे तो मैं आपको दिखाऊंगा. यहाँ ऑफिस में बैठ के तो आप भी ना समझ पाओगे ना मैं भी समझ पाऊंगा कि आप क्या पूछना चाहते हो. See, even for this they are useful, and many such tanks are constructed in Guwagar and Ratnagiri area. In a coastal area, they have this Supari and Narar Bagh. So there they are using it. You can come sometime to that area also. That visit will be also a different, right? But will be interesting. Material required are same, bed mesh, chicken mesh, and all that. Only the steel bar quantity is different when you have different methods. Skeleton first is, we prepare skeleton first, then we wrap this chicken mesh, wire mesh, apply mortar that is in 1:3, and then this open tank gets ready within 4 days. See, at village level, people know how to prepare the plinth, that is jota kasa banna, they know it. So they prepare it, 12 feet dia jota, and then we take remaining material, and on the fourth day the tank gets ready. Any other technology will make a tank in 4 days. And cost is around 6 rupees a liter. So this is about 10,000 liter open tank, is very useful for agricultural and horticultural purpose at village level. So every farmer should have minimum 10,000 liter tank at his house. Now we will see how this 10,000 liter tank is useful for wadi purpose, for giving water. वाड़ी के लिए वाटर स्कीम बनानी है तो कितना पानी लगता है, बहुत सारा पानी लगता है, बहुत सारी बड़ी स्कीम्स होती है. But how this 10,000 liter or 25,000 liter will solve that problem, that we will see. With this 10,000 liter tank is sufficient for 30 or 35 families at a rate of, now it is, they have increased from 40 to 55 liters per day. So it is 10,000 liter is sufficient for around 25 families for a day. Next day again that tank gets filled up like this, and this tank is having 3 or 4 outlets. The water from, they take it out from this outlet. See, this Milind Kulkarni had come, because he comes many times with us at village level. He likes it, and he comes, he probably own, and he gives money also to constructors. So everything he does it. See how these small things can play wonder in village level. They are not huge structures, no, nothing like this. And here we had constructed 2 tanks, but for 1 tank only we taught this mason. Second tank, these villagers, all these tribal people were there, they constructed of their own. And all this water scheme means what, पानी की लाइन लाना, सब लाना, वो सब उन्होंने ही कर दिया उनके हिसाब से. They are very clever. Village people are clever. Only thing that we must trust them, and we must allow them to work. See how this they were happy. These people. Only a 10,000 liter tank plays a wonder. It's just possible. See, this is that Goshala. This was constructed by Vivekananda Trust at Roha. That is Excel Industries. The outlet is this CSR. This trust was there, and this tank of only 15,000 liter is giving water to 100 families. No doubt this, they need to fill this tank 2 or 3 times a day. But even these small, these tanks, the top of this tank was open. So I told them, now you cover it with whatever knowledge you have. Another interesting thing I'll tell you, when you go to any village, people were asking me, साहब इसको कवर कैसे करने का, ये तो ओपन ही रहता है. तो मैं जिस घर में बैठा हूँ, मैं बोलता हूँ इसका घर किसने बनाया? तो बोलते हैं साहब हमने ही बनाया. तो मैं बोला टाकी का कवर क्यों नहीं आप बना पाओगे? टाकी खाली आपको कैसे खड़ी करना मालूम नहीं है. You don't know how to construct a tank, so I come in. For cover, I will not come, and if you see in our book or on our website, villagers have played wonders. They have made covers of different types which you and me cannot imagine. क्योंकि घर में आप गांव में जाओगे और 100 घर होंगे तो 100 घर के 100 छत डिफरेंट टाइप के होते हैं, बोथ इन आर्किटेक्चरल एंड स्ट्रक्चरल. यू मस्ट गो एंड विजिट दिस. तो जब आप आपका घर, खुद का घर बना सकते हो टॉप, तो टाकी का टॉप बनाने के लिए आपको जलवर्धनी या कोई इंजीनियर क्यों चाहिए? तो देन दे हैव नो आंसर. देन दे बोलते हैं कि भैया अपने पल्ले पड़ने वाला आदमी नहीं है, अपने को खुद को ही बना देना है. तो बना देते क्योंकि वैसे वो होशियार रहते हैं. ऐसा कोई बेवकूफ तो है नहीं हो. See, these are different methods. These water schemes are there, and material required is same now. And costing of open tank is 6 rupees, maximum 6 rupees a liter. And we at Konkan region, where this farmer contributes plinth, sand and labor, and rest of the material is given by Jalavardhini in a Konkan region only for needy farmers. Now see this another concept. This is a 50,000 liter tank. See, I stay in Mumbai. I am born and brought up in Mumbai. So in Mumbai I get water every day. So I thought, why not villager should get water every day? Previously standard was 40,000. So for 40,000 means 40,000 into 5 into 365 goes to around 75,000 liter tank. So if a family has a 75,000 liter water stored, then he has not to go outside for at least household water.
For 1 year.
But during monsoon,
How many
he will
days?
collect rooftop rainwater
365 for 1 year.
for 1 year. That is for 1 year. Every year monsoon rain is there. So during monsoon that he will use rooftop rainwater. So he need water only for 240 days. So for 240 days, if he has a 50,000 liters stored water, then what will happen? He has not to go outside to take any other water. तो मैं बोला भाई मैं एक घर में तो करके देखता हूँ कैसे क्या होता है. So we recently have constructed in Guaga this time, and another thing what happens, we have constructed everything for individual. Why for individual? I say if a tank belongs to Mr. Knight, then definitely he will take care of that tank. If a tank belongs to the society or for village, then कौन उसकी जिम्मेदारी लेगा? वो प्रॉब्लम खड़ा हो जाता है. So we thought कि let us go for individual one, so that ownership lies with him. So he will take definitely care, क्योंकि वो care नहीं लेगा तो उसको benefit नहीं है उसका, तो लेना ही पड़ेगा उसको, वो लेते हैं ऐसा. So we are having maximum schemes for individual. So like this, one tank of only 25,000 liter we have constructed. This one at Guaga. So it will be sufficient for monsoon period and 4 months after monsoon. We will see result of this one, and if we get some CSR fund, then we will construct this for individual house. Because any scheme for any village goes in a crores of rupees. So with this 50,000, because this 25,000 liter cost, it was only 6 rupees, that is 1,50,000 only. So in such a small sum, you can construct a closed tank. Of course, it was a closed tank with rooftop rainwater collection system. Online filter also was fitted to this one. So if this if goes well, then we will make more next year. These are the costing. In 6 rupees is cost, but if you get around 8 rupees, that will be a better one. And here also we. So this is all about this storage of water. The small storage also play wonder at this one. We have made, because I am interested in water conservation, we have made one Aaj dam in Alibag also. This one, first marking was done on a ground, anchoring on both sides. Then we had a base, then 8 mm bars. This is our shape. And like this, even this was only 4 feet in height. But such structures you can construct it, and they are very cost effective at rural level. This was 30 feet and it costed only 90 feet at Alibag in some 6 years back.
At least please allow to build column and beam for these dams also.
What?
At least allow us to construct columns for the dam, not for the water tanks.
But they are standing there. See, up to 3 5 see, why they are standing, why they are not? I asked the consultant, आप बोलते हो ना रिप चाहिए, मैंने नहीं रिप प्रोवाइड किया, फिर क्यों नहीं हुआ? फिर आप कैसे बोलते हैं, आपने कितने टैंक कंस्ट्रक्ट किए बताइए मुझे. तो उसके बाद कोई आंसर नहीं. वो भी मैंने लिखा है इसमें.
त्याचे लाईफ टाइम तर वाढू, लाईफ सायकल वाढेल.
माणसाला हार्ट अटॅक येऊन जातो 4 वेळा तरी माणूस उभा राहतो.
पैसे का स्रोत नहीं होता है. आई विल टेल यू, अभी उन्होंने पैसे की बात की तो करता हूँ. With Ferrocement Society, we had appealed to all members. If they give 100, see there are more than 300 members. If everybody gives 100 rupees, one tank of 10,000 liter every month can be constructed with Ferrocement Society's forest. But so far, no, listen to other part, and then I will give his answer. Why provide column and beam? Because life will increase, but who will pay for it? So far, not even one time's money is collected at society's office.
20% have given.
Huh?
20 years, so we have contributed.
But
About
see,
20
everybody
20%
needs, my whole idea was that
Yeah,
every
we are-
month we will construct
we are
one
waiting.
tank with society's fund. See, providing color, I have no objection, but who will pay money for that one? At villages, when I asked, initially I was collecting 25,000 rupees for 10,000 tanks. How many were giving 25,000? Now this year I have 50 application pending from our Kardat area. Where from money will come? If money comes in lakhs, I will provide column and beam to every tank and life will increase. Okay, but then see, anything which goes there for 10-15 years and without column and beam, tanks at pain are standing for last more than 20 years. So I think that's a good enough period for anything at village level. पैसे का शो नहीं करते आता है, आप डिजाइन कैसे भी दे दो उसमें नहीं, वो भी पॉइंट मैंने लिखा है, मैं आपको बताता हूँ बाद में. See, this was a tank below ground. We construct as per the angle of repose. So no steel bars are required. Chicken mesh, whale mesh. So these are right from 10,000 liter to 6 lakh liter we have constructed. And even for 10,000 liter tank, the cost is 2.5 rupees per liter. Beneath the, see, this was recently constructed 6 lakh liter tank at Panvel. This is another thing I'll tell you, ki why I want this thing. This is a government GR which says that ferrocement technology can be used in this one. And in this, they have the photographs which we gave them and they have constructed it. So let us hope that something will be there in a GR which comes from Bharat. We have this so many YouTubes on our website. You can see. Now let us see what question is here. Ferrocement by NGOs and other. There is a difference. As per our knowledge, understanding, NGO generates work. See, we generate work. We go to the villages, we convince people, we generate the work. And at rural level, by spending time and money, NGO explains and shows usefulness of those tanks and the this technology to the farmers and villagers. And then we make them to participate in the work also. They participate 40% in our Konkan region. So many activities we done it. And then again for remaining 60% we have to convince some donor, collect that fund also, then that one time gets ready. But such thing is not in commercial. Many NGOs who are either have successfully contracted this thing. Last year number was but now ferrocement work by not NGOs. How it is done? When some work comes, a consultant gives a design. Because he has the money. Without that, what he will do? He has a design, but no work gets executed. So see, why I am telling you, work at village level is entirely different from urban district. I have no grudge about anything. So the separate thing has to be there for the work at village level. We generate the work, we convince them, we tell them to participate also. And again we raise the funds for the remaining portions. So the entire work system, everything is different at village level and urban level, and that has to be clearly marked in this one. Of course, if it doesn't mark, then nothing goes wrong. We are still continuing it. Not we also, many other NGOs are working.
Okay. Very much. This fruta to el muerto, they say in Spanish. Wish you a happy lunch. Enjoy your lunch.
I'm giving myself introduction. Mr. Chandrakant Patil, currently serving as a project in charge at Macro Foods Private Limited, Panchgani. I'm having a civil engineering experience about 40 years, being as a project management as well as a construction. I have done many projects, industrial, commercial, residential, with Kumar Properties, Mopatlal Spinning Mill in Mumbai, Bridge Candy Hospital, Raymond Showroom in Mumbai, and now working with the Macro Foods. I am very much thankful to the Mr. P.P. Lele, President of Ferrocement Society, given an opportunity to give some details about my project, about the ferrocement. For ferrocement, actually we are very new in this field. We searched for doing one project at Y. We are doing one big project in India as a snow park. It is about nearly 30,000 square feet area. This is owned by Mr. Mayur Vora, who is the owner of the Macro Foods Private Limited. His vision was, we are doing snow parks, so why we can't build a Kailash in that? Because snow concern with the Himalaya, and Himalaya is our, I think, world's center point. So his vision was to build a Kailash. But how we will build the Kailash, that was a question. Then we searched many sites online, how we will build. Then we came to know about the ferrocement. But the ferrocement, we are actually new in this field. So we found one name, Mr. P.P. Lele. Then we decided to call them and have a meeting with them, and will let us know how the ferrocement works. So during this construction phase, Mr. Vora prompted a discussion about the project name. After deliberation, he proposed the name as a Kailash, drawing inspiration from the universal presence of the snow. Our architect, Mr. Srikant Uthile, he is from Satara. He has taken much effort to make these all structures. He made many options for this. Then we finalized some projects design from him. Then after doing all these efforts from the Mr. Uthale, he made from the online contours for this Kailash. You can see in this. Yes. This is a picture of Kailash, originally standing in Himalaya. For this we found some contours on the line, online. Then we implemented this on ground. And then this work we gave to Mr. P.P. Lele to start with this. He made a very good design for this. He will explain all the design part and the execution part for this. I will hand over to Mr. Lele. He will explain everything about the ferrocement because we are very new in the ferrocement, and he will give the details for this. Mr. Lele.
Thank you very much, sir. And I am thankful to Macro Foods also for giving me opportunity to build this old Kailash. It is actually, I can say, it is a Himalayan task for the design also, because architects have taken much efforts to draw the contour map of the Kailash. From the pictures and from some downloading, to scale it up to the required scale, because our actual Mount Kailash is much higher, but we are building in 14 meter height and 50 or 60 meter length. So he made the drawing matching to these dimensions. That is also a Himalayan task, because those who know how the drafting is done and how drawings are drawn, they can understand what is required to draw such things on the paper with scale. Now you can see it here, this is the contour map. This is the contour plan. You can see how these contours are closed and there is spacing between the contours, and there are three mountains you can say. This is central part of the Kailash. This is actual Kailash. This is top height is 14 meters from the base level, and these two mountains they are kept because normally their range of peaks in Himalayas you can see their range of peaks. So this is main peak, that is Mount Kailash, and these are other peaks, and their purpose is somewhat different for that tourist attraction. Because on one part of it there will be some climbing and these things will be there. They are planning like that, and we are making some changes accordingly because some adventure sport like thing will be there. Now
Actually, while planning, the design was made from the photos, scale calculated that I have explained. There was a circumambulation, we call it pradakshina. Normally when everyone visits Kailash, they take a pradakshina to the Kailash. So that provision is also made there. Because if someone goes there with some religious thing, so he can take around.
Actually, Pradakshina is of 52 kilometers around the Kailash.
Yeah. He has studied Kailash very well. He can't tell anything about the Kailash now.
Yeah. It is a 52 kilometers around the Kailash we can walk. It will take near about 10 days to complete one Pradakshina.
So it will
concept also we have made in this.
In this
we have one staircase to going up and
here you can see
Parikrama
from
of
here
Kailash.
we climb the stairs,
Yes.
go in the there is a ramp here and come down from this way.
Yeah, it will
That-
be one Pradakshina.
That will be one Pradakshina.
How much distance?
Here it is near about 52 meters.
Okay.
And there actually it is 52 kilometers.
Okay.
It will be 50, say this will be maybe 150 kilometers taking all around. So various services are also required in such thing because air conditioning is one of the most important services because that temperature will be there around -5 or -6 degrees. So this they have built a shed first and it is insulated all around. And in one part of the shed they have made cold storage. Roof is also insulated and one
Cold
part
storage is of -20 degree temperature.
they store their strawberries there and they are using that. Inside there will be meditation rooms also. Adventure sports, just now I explained to you.
Below the Kailash there is a much space open inside. So we are using it for a meditation or any other purpose.
Meditation rooms will be there below the Kailash. AC and also cleaning of ice or snow is also required. So some drains are provided in the flooring.
We are buying brooming machine that will be brooming in the night. The ice which will be the dirty in the daytime, that will be broomed in the night. So next day it will be fresh.
And they are also brought a snow making machine. That
We
will
are
be
having
there.
the 3 snow making machines. So we will make a machine at a spot. Even on Kailash we are going to have a near about 300 mm thickness of ice. So that load is also considered in the design.
Now ferrocement design and planning comes in picture. There were some requirements and constraints for the design. Shape, as you have seen, shape is important. Just erecting any mountain is not desirable. The shape has to be there exactly as per the photograph. It should look like that same photograph. That was the most important requirement. Structurally, it has to be safe because people will be going around. So it has to be safe. Space below has to be utilized. Otherwise, it would have been very easy. Just make a mountain of masonry or stone and bring the shape. But it is not the case. That space below should be utilizable. And one more constraint is there because they had done the flooring. And below flooring, they have run some pipes.
Yeah, we are having PEX pipes inside the floor to run a glycol which keeps the floor cool. That is the main actually, we can't disturb that pipes. The PEX pipes of 12 mm diameter, we will running the glycol liquid through the pipes because glycol liquid keeps floor cool.
Ethylene glycol?
Ethylene glycol, right.
So,
because of that only we can't drill anything in the floor. Above that we have made one raft of 200 mm thickness, both side reinforcement. And on that reinforcement we have built the structure without any puncturing. We did only rebarring. Pardon?
Temperature outside the tube, glycol tubes or in the floor?
It will be minus 20 degree.
Minus 20?
Yes.
Glycol freezes at?
Minus 13. Minus 13.
So we had a limitation. We cannot drill the hole deep inside. Maximum 50 or 60 mm. He said that you cannot drill the hole more than that. So that constraint was also there. So our structure has to be self-standing. That was a requirement. And without taking any support from the structure, because they have erected the structure, but we cannot take the support of that structure for the shade. So it has to be self-standing. That was another requirement. Then how it was designed? Firstly, we marked all the contours on the floor with full scale, required scale, because that 14 meter hand and length 50 meter or something like that. So all the contours were marked on the floors. Grid, we marked a grid of 300 mm by 300 mm. So when all the contours were marked, I found that between the 300 mm, contour lines are straight. So it is clear that if we erect and made the straight lines between 300 mm, we will get the exact form of the contours. So we decided to go that way. Initially, supporting structure is required. We cannot just make a ferrocement slab or wall of that 30-40 mm thickness and give the shape. It is not possible. So supporting structure has to be there, because the span, widthwise span was also, I think, about 15 meter or so. So naturally, two ends, two walls were spacing 15 meters apart. So that 15 meter span is much more. We can, and again that shape of the wall is also not straight or inclined. Place surface not there.
Angulation like
all the angulations were there. So initially we decided that we will keep the framing at support at 1350 mm spacing, because that is optimal span for the spare cement. If the span is more, then we have to increase the thickness. And for 30 to 40 mm thickness, 1350 mm is okay, that is fine. There will not be cracking or bending, anything like that. But later on we changed to 1200 mm, because that support, vertical supports were there. And in between the space, in between the two supports, 1200 mm was equally dividable. So that's why we made it 1200 mm. We also thought of keeping main support at 2400 mm to avoid vertical supports in between. But later on, we come to know that if we keep it 2400, we need support at 1200 mm. Then cross beams will be there. So there will not be any saving. Again, for design purpose, we have to draw the section in both the directions to work it on. So that idea was kept apart, and we made the frames at 1200 mm center to center. Now section, as already explained, section, we get the section from that contour plan at 1200 mm, and every section was drawn on the drawing. For every section drawing was made. Vertical support were provided at the ends only, because space below should be utilizable. So there are far minimum vertical support in between. Practically there is no vertical support in between. All the supports are at the end only. What happens if an internal surface is there and irregular surface? We have to tie opposite ends. So we provided tie beams at connecting opposite ends at certain intervals. At bottom also we provided a small tie beam, because that's how it will pair. It will go, two ends will go apart. So tie beam is necessary, and anchorage in the flooring was not possible. That's why we provided small tie beam with some minimum inserts in the floor that make the depth of tie beam minimum.
Do you have pictures? Pictures that can
Pictures are there. I am explaining design detail. There's many photographs are there. There's number of photographs are there. And actually it is better, I advise you to visit the site. And site I can explain you better. And there is always limitation. The span is too much. To show all the pictures of every part becomes difficult. That tie beam, depth of tie beam was much more due to the span. Minimum span to depth ratio we have to maintain. So while concreting, we know that below neutral axis, concrete is redundant. In the company, they were having many pieces of insulating material because they have provided insulation at many places. So we use those insulating pieces in the concreting, above that bottom layer and below the neutral axis, to reduce the weight. Also some cost is reduced in the concreting. That we did there. Instead of making beam hollow, use those insulating pieces, thermocol lightweight. The insulating material pieces are there. Some steps are also planned in later stage, exact how much steps are required to calculate accordingly, and some provisions are being made. On the paper they are made, practically they are being executed. You can see on the site visit. So execution stages I have already explained. First marking of plan, making frames on the floor and fabrication, erection of frames. Now I'll show the photographs, and this is the actually picture of the frames. Initial stage. Because after making the design, architect made this picture.
There are total 38 ribs.
38 frames, we can say.
38, starting from that end to this end.
Total 38 frames are there, and you can see the top of frames.
You can use the mic. You can use the mic.
Top of frames, if you join the top of frames, that will give the shape of that mountain. That's how we made the frames, planned accordingly.
टॉप टू टॉप जोडत गेलं तर तुम्हाला तो मिळतो.
That's you will get the shape. These are the initial frames. These were erected. You can see the person standing on the frame. And these frames were erected with the help of crane. And totally here those pictures are difficult to see because there is, you can see two beams running, joining the columns.
There are tie beams between
structure,
old structure which is built in the PEB structure. So because of that beams, there is a disturbance to erect these type of ribs.
These frames, we could not make a frame just erect only. We made the frames, cut them
in two parts.
Erected one part first, another part then, and again joined in the place.
Rewelded.
Yeah.
And for that we use some angle clicks with bolting. Before cutting the frame, we provided angle clicks and bolt in between, cut between those two, and then with the bolt exact position were achieved.
Then that joined it.
Exactly the same profile we got. You can see here how, and we started with the highest
first,
first,
which is a 14-meter height. That rib we have started first.
We started first because water problem will come. That will be sorted out in the first 2-3 frames only. Then there will not be any problem. Start from the difficult, then everything will be simple and easy. So we started from the difficult portion.
For this actually we got an advantage of the contour plan. Without that contour plan we cannot done this.
Here you can see the shape, exact shape that you have seen earlier. I show that photo again now.
This shape is almost we have achieved. You can have a look tomorrow.
This is the shape initially we had in mind, and after erection.
This is only on this axis. How about this axis?
No, that is actually
backside.
Backside actually, you have seen in the photo, there is a ramp.
Okay. No, actually for the snow park on the opposite side, we have made up slope rides for the visitors.
Here you can
there are some sloping rides behind.
Acha, skating.
This is the north elevation which is looking as in the original Kailash. That only we have faced from this side. The back side is not we have done much.
Because everything is required in one place. Snow park and adventures and everything, and also with Kailash. That's why only that portion is used.
Only elevation purpose is finished.
Yeah, elevation and some side elevation also, some partially.
Sir, back. एक मिनिट back लागेल. अजून back.
Here you can see that there is a ramp.
Ramp.
Back side.
And here, these steps are going up. Actually, then later on we match these steps with the ramp. People will go climb up from this step over the ramp. From here they will come down. This person redesigned later on, and they are coming down from these steps. And some adventure sporting will be there.
Yeah.
They will be climbing from this way, going to this.
There will be a Burma bridge in between that highest rib and that sloping side. There will be a Burma bridge.
In between. That is for some adventure sport. That portion is now later on redesigned, and we are working on it now.
Yeah.
Have you thought for the physically challenged people also?
No, physically challenged people you cannot climb this, you cannot go in the
Ramp and all these things.
Yeah, that we have taken care of. We are putting escalator for them to go up.
Grandchildren are playing grandfather wants to just go around do pradakshina.
That may be possible, depends.
The bottom is a column.
Yeah. This is vertical part.
Vertical part.
This is vertical part. It is like a column.
Okay. Acting as a column.
Acting as a column.
We are about 400 mm width.
Best.
Okay.
Very nice. Good.
Now this is mortaring, you can see it here. Mortaring work is going on. And you can judge the scale because you can see a person standing here. And this is 20 feet ladder, and you can judge the scale of the.
Yes, yes.
Press filling from both sides or single?
Both sides.
No, press filling actually, everyone was telling that there is no need of shattering for the ferro cement. But personally, in my opinion, when we learn that we insist on your specific surface, that bond between the meshes and mortar has to be perfect because we count on it. If we press it from one side only, even though mortar comes out from other side, that it is thought that there is no need of pressing it more. But I tried here, I fixed 3 mm ply from the bottom. I tied it to the meshes because shape is confirmed that shape is not disturbing. So after tying that plywood from below, I initially finished that surface with press filling that we normally do. Then I use needle vibrator with 25 mm needle. And then I observed that mortar goes down. That means there is some voids in between. That's why it is going down. And cement water is coming out later on also. So that is the area for the study also. Many academicians can study over it, why it goes down, and properties with press filling by hand and with using vibrator. What is the difference? That you can search this, make a research over it, and I will be happy if I get the feedback. Basically, if we use plywood from below, that cost is not much. Increasing the cost is not much. On other hand, we can save finishing labor from other side. That may be making the cost same. So practicing people can think over it and use this practice. By the way, it is not included IS code.
What is not included?
This use of shuttering or anything. We are not including IS code. IS code is keeping silent over it. So this is another mountain. You can see in another picture that mountain, second mountain. It is not Kailas, but in Kailas range. That is, I think, imaginary or something like that.
Yes.
It is imaginary because to make that in Himalayas you will find there is always a link of
Mountain
peaks.
range.
Mountain range is there. Small, bigger peaks like that. This is another view that work is going ahead. Actually, it was difficult to take photograph there because it is in the enclosed shed. So light is very low. So I brought the photographer and he came with some floodlights and everything.
Actual picture we can see tomorrow.
Yeah, tomorrow you can see actual picture of it.
Mapro is inviting all to come.
So we'll take a review of tomorrow's tour also.
Yeah.
Number is to be decided.
So thank you very much.
It's a great and challenging job.
And any questions?
सर
Yes.
मला फेरोग्रिडचा असा कौतुक करायचं.
Jam, you have dosa, you have jam and then at Mapro. Thank you very much. One, I think picture, one more picture.
Mr. Deepak Kanere. Yeah, you are ready.
But unfortunately, when I was working with biogas, I came to know about ferrocement. I am here to show you different reforms in ferrocement, what I have made. This is a foot over bridge made in Udaipur, Rajasthan. I have trained 3 engineers over there and they have erected this. This is just what different reforms we can make in ferrocement. This is just for your information.
I'll do it. You keep talking. Okay, next.
This is retaining wall. Retaining wall in petal shape. At Panchet, we have constructed it. A very heavy slopey land was there, and I have made these 4 retaining walls over there, and the whole area has been the whole area.
You can stand there.
The whole area was again utilized for different things. This is a resort at Panchet. Retaining wall is a beautiful example for ferrocement, where hilly slope can be avoided and make it a plain thing. There is a swimming pool made at Bhor, Varanghat. This is not lined up with tiles, only painted. This green color paint has been applied onto this. A very beautiful structure we have made at Bhor. This is again at Udaipur. At Udaipur there is one forest hilly area. Over there just a watchtower they want to have, and I have made a separate staircase at the right side, and over on the top a watching tower, a sort of observation point is done. Next. In ferrocement the slabs are made. At the downside, the ribs are to be constructed. That is the photograph. This is a swimming pool, again, huge swimming pool. This is around 76 feet in length and 40 feet in width, 7 feet in height. The retaining walls have been included into this design. Next. This is again the retaining wall. Next. Retaining wall. Swimming pool. This is a water tank of around 50,000 liter made up in ferrocement. This is part one.
Before क्या?
Inflatable dome. What Mr. B.N. Divekar has told me about this structure was inflatable dome. I have earlier executed and then named by Dr. Divekar is inflatable dome. The beauty of this structure is I would like to add one thing more into the history of ferrocement. Yesterday you must have listened to somebody who has tested ferrocement for heat retardant, or secondly the question and that snow, the temperature range. This is positive, this is negative. I would like to add in this is the structure can be made not only leak proof, this is gas proof. Or liquid molecule can pass through. So we can add some mortar onto this and we can make it leak proof. But the gas molecules are too small that they passes through. But I have made this structure gas proof. So ferro cement is not only liquid proof, this is gas proof. Next. This is a dome, square shaped dome. Next. This again a swimming pool made in Nanded. The beauty of this structure, the tiles inside this beauty swimming pool are of different sizes and different in composition. Like जो आदमी था, ये आदमी ने दुनिया में से इकट्ठा करके टाइल्स लाए हैं, हाँ, free of charge. Discontinued tiles can be utilized and the money can be saved. That's why I have shown the picture. Next. I have made 1+1 building at Nanded. This is a structure, a photograph taken from bottom side. The ribs and ridges you can see. The columns are in plus shape, T shape and L shape. This is the Kalash we have made at Nagpur. You can see the beauty. Even the mango petals are there. They're very beautifully shaped and painted. This is next. This is a bandhara. I have made it at Nanded. Padma Shri Anuradha Podwal has financed it. The two the two bandharas I have executed over there. At the downside of the stream, there was one KT ware. The KT ware's budget was 25 lakhs. And these two ferro cement bandharas costing 18 lakhs only. I have saved 7 lakhs rupees in this structure. And fortunately, these two bandharas were full of water, and the downside stream of the KT ware, which was erected by government body, was there. The passing canal like this from the downside of the KT ware. So this is important that the structures in ferro cement are economical, rigid, and trustworthy. This is my basic business of biogas. I used to make domes out of this, different sizes of dome. I have made 200 M-cube dome out of this structure. The stairs. Next. Thank you. Any questions?
Those columns and beams are absolutely.
Basically, he is a mechanical engineer, just like Nanda Kumar Zalo. Both are mechanical engineers. Okay. They are working on civil engineering.
Good afternoon, everybody. I am from Kerala. I am focusing in ferro cement homes only. Then one project is at the ferro homes, we empower individuals in our community to foster innovative concept and explore the vast possibilities of ferro cement construction. By detailed analysis and discussion, we understand the need of every client and help them fulfill their dream home, villa, office or any other constructions at the best price and quality by incorporating our innovative concepts. This is my project. Details. 2,500 square feet, 2-floor, 6-bedroom house, consisting of our construction phase. By ensuring equal load distribution throughout the construction, we successfully completed the construction in 5 months. Photos, please. And also, please wiring it. Interiors. Total cost item is labor, steel, cement. Total 28 lakh 15,370. Cost comparison. Traditional concept in Kerala 200 per square feet. It is but Faro 1,120 per square feet. 49% construction cost low. Time comparison. Traditional construction is 15 months, but Faro 5 months. Time saved is 66% time saved. Space analysis. Traditional construction 20 centimeter wall thickness. Faro cement construction 8 centimeter wall thickness. Approximately 20% additional carpet area. Faro cement have huge opportunities in Kerala based on the region specific context, such as heavy monsoon rain, humid and coastal environment, landslides and soil erosion which permanently damage the traditional constructions. Okay. I am in Kerala, I am from Kerala. Let me say few words in Malayalam. Okay.
Please continue.
Okay. Sebastian from Kerala. Kerala is a beautiful country, God's own country എന്നാണ് പറയപ്പെടുന്നത്. അവിടെ സാധാ കൺസെപ്റ്റിനേക്കാൾ കൂടുതൽ നമ്മുടെ നിർമ്മിതികൾക്ക് വളരെ സൗന്ദര്യം, വളരെ ഇന്റീരിയർ ആൻഡ് എക്സ്റ്റീരിയർ ഡിസൈൻ വളരെ കറക്റ്റായി എങ്കിലേ അത് വർക്കൗട്ടാണ്. സാധാരണ ബിൽഡിങ്ങിൻ്റെ സമീപനമല്ല അവിടെ വേണം, കുറച്ചുകൂടി ആർട്ടിഫിഷ്യലായിട്ട് വേണം.
He is saying that for a successful completion, everybody looking the interior side, the beauty, more than any other thing. He is saying so. Hello. He is saying that the beauty is looking in Kerala, in the construction stage.
അപ്പോൾ ഓരോ വീടുകൾക്കും എന്താ വെച്ചാൽ വീടുകൾ വളരെ വൃത്തിയായിരിക്കണം, ഭംഗിയായിരിക്കണം. സ്പേസും ഡ്യൂറബിലിറ്റി, സ്റ്റെബിലിറ്റി മാത്രം പറഞ്ഞാൽ പോരാ, ടോട്ടലി അത് ആൾക്കാർക്ക് അഫോർഡബിൾ ആയിരിക്കണം, സ്വീകാര്യമായിരിക്കണം.
In Kerala, when we looking for stability, they are looking, same time they are looking beauty also. Then only people will accept the construction. At the same time, they are looking economic side also.
അപ്പോൾ ഞാൻ പറഞ്ഞിരുന്നത് നമ്മുടെ ഈ ഒരു കൺസെപ്റ്റ് ഞങ്ങൾ എടുത്തിട്ടുണ്ട്. ഞങ്ങൾ മനസ്സിലാക്കിയത് ഏതാണ്ട് 45% നമുക്ക് ലാഭമുണ്ട് സാധാരണ കൺസെപ്റ്റ്.
He is saying that around 49% cost we can save from Faro construction when comparing to traditional concept or traditional construction.
അപ്പോൾ നമ്മുടെ ഗവൺമെൻറ്റുകൾക്കും മറ്റ് എൻആർജികളും വീടുകൾ നിർമ്മിക്കുന്നവർക്കൊക്കെ ഫെറോ സിമെൻറ്റിൻ്റെ വീടുകൾ ഉണ്ടാക്കിയുള്ള ഗുണവും എല്ലാവരും നമ്മുടെ അസോസിയേഷൻ മുഖാന്തരം അല്ലെങ്കിൽ ഈ സൊസൈറ്റി മുഖാന്തരം കുറേ കൂടി എക്സ്പ്ലെയിൻ ചെയ്യേണ്ട ആവശ്യമാണ്, ആൾക്കാരിലേക്ക് എത്തിക്കുക, ഗവൺമെൻറ് സെറ്റ് ഏജൻസികളിലേക്ക്.
He is saying that via this association, with the help of association, we expecting the support from Kerala, I mean government.
Okay, thank you.
Thank you.
1 minute, sir. 1 minute. Sir, some more, sir.
I'm a student of this college, 1976 batch. I am mechanical engineer, but in last 20-30 years of my profession, I work for various industries, right from aeronautics to food industry. 15 years back, I was introduced for dam instrumentation in Maharashtra because I was involved in some kind of instrumentation where I started working on Koyna Dam for earthquake measurements and other things. And we made our own sensors and other things where local solutions were not available. Later on, my work was appreciated by CWPRS, which is a government agency, central government agency. Then other agencies like MERI, KERI were all involved in the state level dam instrumentation and dam rehabilitation and maintenance. That is why I came in touch with civil people. Because of that, I could meet Mr. Lele and Mr. Hagekar sir, who was the Dam Safety Committee Superintendent in Nashik. Point is, basic mechanical engineering is required in a different way to understand the problems of civil engineering. Now, this Ferrocrete Society, I was working for them on certain areas where I understood that the basic arrangement is of a composite, that is the steel mesh and then cement which is put into it by a mason, by some hand and skill. And it was a tedious job, and of course with that there is some problem of getting a quality material or quality job. After understanding that and then getting some challenges from some customers, I was asked to design something which can be used for this kind of operations. So what you see here is one machine. This is the third or fourth model of mine. I am working on this for about last 6 to 8 months. I'll just explain it what is. Now what else, last 2 days you have been seeing it here. You are seeing the finished jobs. Basically when the mesh is made and the thing is standing all on its own, the mason is putting the cement from one side and finishing it off. Basically you require support at the back, which is normally done in the case of making a tank or some sort of thing, which were exhibited to me, and I worked on that. Now what happens is when you put a cement using hand and that gamela and all that kind of thing, how much time that person can do the job with the same skill, same passion, same strength, and how can you ensure that the job which is done is having a good quality? You absolutely don't know what is the density going inside is uniform or not. Meanwhile, this particular material, that mortar which we are using, is having minimum possible water. So by default itself, it hangs to the wire mesh inside, honeycomb. But that doesn't mean that isn't made a very good joint over there. And maybe after a certain time, or maybe tomorrow, day after, or maybe after few months, you will understand that the job was not done properly. Now it is not known at that moment what was the quality of the job. The only thing is you are depending on that mason or that team who is doing this job and the handwork which is made by the frame, that steel bar frame or whatever that mesh frame is made. This machine was particularly thought of saying that I should do a job with effortless action, and I should do that job with such a strength that the cement goes and ramps into the material so that it forms a good bond. This is a mechanical technology which is normally called as the blasting. Now if you have to have good bond, there are 2-3 things. One is the contact area, at the same time a forcible contact positioning, which is a chemistry part of cement. That it should get some time to have a bond. Like when we say that we give some time for wetting, that maybe there is water, but water may not wet the surface totally in one go. You have to give some time for wetting also. Like that, there is some time required for forming a bond for cement also. This is what I understood from the chemistry. Now this particular machine, as you see here, this is made particularly for one Mr. Patankar, who is working on big tanks in the Rahuri area, and 6 months back he said that I want to do it this way. So we made it for him, and he will be taking it further because he is involved in all ferrocrete activities for last so many years. This particular photograph shows that a person is holding this unit. It's the first model. It is on the belt, so he puts the belt across so that the weight of this machine goes onto body. He doesn't have to hold it. Then there is a motor over there. You can see it here. This looks like a grinder motor, but it is not the normal grinder motor. These electrical properties are altogether different, and we have to get it done from some arrangement with some electrical winders and those kind of people who can give this hardware. Point is, all the grinders which are working over there, they are normally working at about 13,000 RPM. Now that RPM cannot be useful for our kind of work. It generates some different type of problems. At the same time, we require some horsepower. Now this unit gives you almost 2 horsepower, which is a very big horsepower for this kind of operation. Point is, similar applications were tried by somebody earlier with compressed air. And the compressed air is so costly on site, as you know, minimum 5 HP compressor is required, and all that air is wasted ultimately. And believe me, air is not free. So other problems with compressed air and other things were there, which did have some problem with the consistency of job, at the same time maintenance of the compressed air. Now this particular unit becomes standalone, very easy to handle. This unit requires minimum possible time for finishing the job. As I mentioned over there, there are few points which are important as far as this feature is concerned. As I said, this is a portable unit. Now you can see that it's hardly 6 to 7 kilos. This particular funnel is given to hold a mass about 20 kilo of water. Then there is an entry point, then there is a turbine, and then there is a centrifugal force blade with some typical properties. And then there is a drive with a switch on that, plus a speed control. Now these things are not available in any of the machines. What happens is that when you change the speed, centrifugal forces change, and accordingly the throw of the material change. So if you have to do jobs something from very near, very small distance, you can change the speed. If you want to give a bigger throw, you can change the speed. At the same time, if your motor has got different densities, you can change the speeds. Point is, this material goes through the system so fast that about 20 kilo mass is finished in 1 minute. You can imagine the rate of work. You have seen, you have made so many jobs. The masonry work which takes about 1 hour, he can finish in 15 minutes. So you can imagine the fatigue which is removed. Secondly, that person will love to use this machine. For the same reason that he finishes the job fast. The finish is good, quality is good, and he doesn't have those efforts. What only he has to do is, he has to do it, handle it properly. That too we are taking care that some belt is given so that the weight goes on his shoulder, not on his hands and all. What is required is that he requires continuous filling. Because he is consuming it so fast that normally his helper coming with gamela. They take time, but here in this case, someone has to run and feed him because he is doing it so fast. That is why we say that there is another connection, that if you have got a concrete pump, you can connect it to this. So continuously also you can do it. It's my dream that someone should use it on a bigger job. Maybe Mr. Patankar himself will do it when he is doing very, very big jobs. And point is, this machine doesn't require any maintenance. After finishing his job, he just can put bucket full of water and run the machine. Machine is clean. There is no wear and tear part. Unless some big time is passed, maybe 10 years, 5 years, whatever it is. But at the same time, this electrical part needs normal operational care that he has to take care. Things are totally made in India type. Absolutely no hassle in that. As I mentioned on those various points, I'll show you one or two small videos which will show how the development came up. Actually, normally it should not, but it sticks to it because strength is so much that that bond is formed. There is some chemistry working on that. I can't explain. But it happens that when you want to remove it, one more time, and then second. Very small videos. Sound there. Second one.
Second also.
I think.
Yeah, this is second one.
It's a little improved version with a higher capacity. Just see the lumps which are getting on it. What person is doing is he is just directing. We can concrete testing and other things are there. But at least you should know that job which you are doing, whether what quality you have produced, is it consistent? Whether Mr. X has done that's why the job was okay, and Mr. Y could not do that. That should not be the case. Any small, I can say even a lady can operate, even a helper can operate, and they will be having a pride in it because these people have that mentality that I am given a machine. So I am not an ordinary person. I am with machine. So they take a pride in it and they do job. Anyway, thanks. This is what I would like to suggest. Let us see that you, with your all blessings, you should go further. Thank you very much.
Questions? 3 पॅनल्सची कृषी, कारण समजा आग लागली आणि फेल्युअर कसं होऊ शकतं, म्हणजे साधारण एखाद्या आगीनंतर फेल्युअर कसं होऊ शकतं, तर समजा लाकडी असेल तर ते जळून जाईल, स्टील असेल तर ते मेल्ट होईल. तर कॉन्क्रीटचं काय होऊ शकतं, कॉन्क्रीट शॅटर होईल, म्हणजे फुटू शकेल किंवा त्याला मॅसिव्ह क्रॅक जाऊ शकतील. अशा प्रकारे फेल्युअर म्हणजे आम्ही ते IAS मध्ये वाचलं सुद्धा आणि त्याप्रमाणे टेस्ट घ्यायचे ठरवल्या. मग आम्ही त्या फायर गन्स विकत घेतल्या. 1300 डिग्रीज टेम्परेचरला साधारण 2 ते 3 तास आम्ही ते कंटिन्युअस त्याला फायरनी चेकिंग केलं. फायर 1300 डिग्रीजपर्यंत आम्ही तापवलं आणि त्याच्यामध्ये नंतर काय इफेक्ट किंवा काय फरक पडतो आम्ही चेक केलं. तर पहिले आम्ही 6 पॅनल्स कास्ट केली होती. 3 पॅनल्सची क्रशिंग स्ट्रेंथ, आता कॉम्प्रेसिव्ह स्ट्रेंथ आम्ही चेक केली आणि बिफोर हिटिंग, आणि नंतर जी 3 पॅनल्स होती ती आफ्टर हिटिंग अप टू 1300 डिग्रीज, त्याच्यानंतर आम्ही कॉम्प्रेसिव्ह स्ट्रेंथ चेक केली. साधारण 5 to 10% पर्यंत मिनिमाइज झाली, स्ट्रेंथ मिनिमाइज झाली. म्हणजे आम्ही जी ऑब्झर्वेशन जी बघितली ती साधारण 10% पर्यंत समजा ती स्ट्रेंथ मिनिमाइज झाली, जी काही एवढी जास्त हे नाही आहे, प्रॉब्लेमॅटिक नाही आहे. नंतर आम्ही तो पॅटर्न चेक केला की मी मुलांना काय सांगितलं की तुम्ही हिट करा. म्हणजे आता एकदम लॉजिकल आहे, म्हणजे आपण कसं लॉजिकल आहे, उगाच IAS-BS आपण गाईडलाईन तर घ्यायची, पण प्रॅक्टिकल काय उद्या मला घरी आग लागली, माझ्या घरी आगीचा बंब विजवायला 1 तासामध्ये येऊ शकतो. तो पहिल्यांदा जेव्हा पाण्याचा फवारा मारेल तेव्हा ती बॉडी काय ॲक्ट करेल ते मला चेक करायचं होतं. त्याप्रमाणे आम्ही 1300 डिग्रीज कंटिन्युअस 2 ते 3 तास हे केलं आणि सडन लगेच हे त्याला पाण्याचा फवारा मारून ते चेक केलं. फार मायक्रो क्रॅकिंग झालं, म्हणजे असं काही शॅटरिंग झालं नाही, कुठं मटेरियल तुटलं नाही, फुटलं नाही, कुठेच काही त्याला प्रॉब्लेम दिसला नाही. म्हणजे रादर की असं म्हणता येईल की बाबा अरे याला फुटू शकतं किंवा वापरू नाही शकत असं, तर असं कुठंच झालं नाही. पूर्णपणे इंटॅक्ट राहिलं मटेरियल फेरोसिमेंट. आणि मी या कन्क्लुजनला आलो की फेरोसिमेंट इज द बेस्ट मटेरियल फॉर फायर फायटिंग. थँक्यू.